So you already did the do now quiz. I didn't get to look at them yet because I couldn't get into the building to get them. So they're not going to take long. They're going to be all perfect, right? Yeah? Cool. Yes, you got that, right? All right, what I want you to do is find the antiderivative of 2x minus 3 squared. And then tell me if it's the same, like after you get your answer, as if you had just taken the antiderivative using the power rule of the whole thing. Like if what you get is equal to 1/3 2x minus 3 cubed. And I've done the 2x minus 3 cubed for you. You're welcome. So get the the antiderivative and see if it's 1/3 of that. Now let me pause this. All right, so what about for this do now? What do you have to do to integrate 2x minus 3 squared? Square it out. What do you get when you square it out? Good. And then when you actually take the antiderivative term by term, what'd you get? 4/3 x cubed. Okay. Oh, plus 9x plus 6. Okay. So, this was not bad because all we had to do was square it out. But imagine if we were trying to integrate 2x minus 3 to the 9th, right, or to the 10th. We had to multiply it all out first. Ay, ay, ay. So, I was just wondering, hey, what if we just integrated the outside function like we normally do? Just add 1 to the exponent and multiply by the reciprocal. Now I have what this is. I actually cubed it out here for you. If we distribute the third, this is the third out here, we would have 8/3 x cubed minus 12x squared. No? Just distributing the 1/3? Okay. What's 1/3 of 54x? 18x. And then minus 9. Oh, so we can't just do that. But we're off. So the answer is no. By what factor is our answer off by? By 2. Where do you think that 2 comes from? Yeah. Oh my gosh, I couldn't have said it better. It's the derivative of the inside. So we're going to be able to use the power rule. We're going to work the chain rule backwards with something called U-Substitution. Yeah, we're up to this because we're off. I'm going to write here off by a factor of 2. And so I'm going to show you how to do this so you won't be off by a factor. And you can use a real quick way to integrate. You won't have to expand a binomial to the 10th. Or we're going to be able to integrate compositions of functions. Exciting? Oh, yeah. Oh, yeah, it is, whether you know it or not. But first, I gave you the answers to the differentiation integration practice, but I never gave you the answers to, I think it was day 60, 19, day 60. You had done I gave you answers to 1 to 18, but then there was 19 to 32. And I want to go over that first because tomorrow you're going to have a quiz, 10 multiple choice questions just like from this handout. So if you look back to day 60 notes, and you probably corrected 1 to 18 already, but I don't think I ever gave you the answers. So your quiz will look just like these, multiple choice, 10 questions. Yeah. Okay. Oh, I should just give you the notes. It doesn't have the, I don't think day 61 had the answers. Let me just check. Oh, I did give you the answers to 1 to 18 on it, so yeah, you need that. Here, just pass that, Georgina. Yes, Ryan. 28, 26, 32, 20. Okay. All right. Does anyone need more time to look at the answers? Yeah. Okay. I'm on the wrong now. I should get my own copy. Okay. You're ready. Got it? Yeah. Okay, I'm going to go over some that I already have down. No, that was not one of them, 22, right? Did anyone want 22? No. Well, 22, you had to know the identity. You have to know your three Pythagorean trig identities. Sine squared plus cosine squared of an angle equals 1. And then the other two you get by dividing through by cosine squared x or sine squared x. So yeah, you just replace that with the identity and integrate term by term. That wasn't the one. I think the 26. Anyone else 26? Or 26? Okay. So they tell you the slope of the function is 4x minus 1. So that's the derivative. And they tell you that the actual function itself goes through the point negative 2, 3. So to get from the derivative to the function, you take the antiderivative. But when you take an antiderivative, you wind up with a plus c. So the antiderivative of 4x minus 1 is 2x squared minus x plus c. To solve for c, you got to use the point that they gave you. So I had to plug in 3 for y and negative 2 for x. Yeah, you're right. That is going to be that. And when you solve for c, it's negative 7. And you just pop that back in, and you have your function. Any confusion, ask. On this one. This one's all right? I know 28 was one, so I'm just going to go over the ones that I already put up here, and then I'll go back. 28, they tell you that the acceleration of some object moving along the x-axis is k, or k is a constant. So velocity is the antiderivative of acceleration. When you integrate a constant with respect to time, you get kt plus c. Now, they told us that the velocity at time 0 is equal to 1, and the position at time 0 is equal to 1. Once you've integrated acceleration, you have your formula for velocity, you have your plus c, you have to use a point on the velocity graph to solve for c. So we're going to use this point there. We're plugging in 1 for the velocity, 0 for the time, and we solve for c, and it's 1. Now we know the velocity function, v of t equals kt plus 1. So when you integrate, you're going to have a plus c. You got to solve for c before you can go and integrate again. Now we integrate velocity to get position. So we have to integrate kt plus 1. And when we do that, we get 1/2 kt squared plus t plus c. So now we're going to use a point on the position graph. It told us that the position at time 0 is 1. So we'll put 1 in for the position and 0 in for time. And that's going to allow us to solve for c. So c equals 1 again. And so our position function is 1/2 kt squared plus t plus 1. Any questions? You didn't get how I started or anything? Then there was, I think, a 30 or 32. And then I'll go back because I know I skipped some. Does anyone want 30? Is that one of them? Yeah, okay. So in 30, they give you the acceleration, no, they give you the velocity. It's 5t squared minus 20t. And you want to come up with position. Sometimes I use an x instead of an s. You just go with it. So I'm going to take the antiderivative of velocity, get position. That gives you a plus c. You have 5/3 t cubed minus 10t squared plus c. Use the point on the position graph they gave you. You plug in 30 for position and 0 for t. And from that we get that c equals 30. Now we have the position function. 5/3 t cubed minus 10t squared plus 30. They didn't just say get the position function, they said find the position when t equals 3. So once you have your position function, you had to plug 3 in to solve. You could plug any time in and get its position anywhere. Copy it. 31 was kind of cool. Did anyone ask 31? No? 31? At rest means the velocity is 0. So you had to get the velocity by integrating acceleration. And once you had the velocity, you figured out the c, you still had to set it equal to 0 and solve for t. What? Yeah, and that was that crazy fact, right? Okay, tell me the other ones I haven't said that you guys, 32, okay. And anything else other than 32? No? Okay, let me see what 32 is. Oh yeah, 32 I have here. I was trying to anticipate the ones you were going to ask. The 10 is a constant multiplier. You can just pull it out front. So if you pull the 10 out, you see you're just integrating 1 over 1 plus x squared, or 1 over x squared plus 1, same thing. And that's the inverse tan. So you just pull out the 10. You have 10 times the inverse tan of x plus 3. Anything else? Okay. So you'll have 10 multiple choice questions tomorrow. So we're starting U-Substitution today. This is exciting. I'm going to basically just use it with the power rule. But once you get the hang of it, you can use it with any rule. Yeah, this is good times. Oh, this is good. Guys, we're going to start out by differentiating. Tell me what the derivative of 1/12 times the quantity x squared minus 1 to the 6 is. Bring down the 6, so you have 6/12, or 1/2 x squared minus 1. Well, we're taking the derivative, the 5th, right? You multiply, write it, and go. And then times we're using the chain rule to take the derivative of a composition of functions. So we got to multiply by 2x. Can I clean that up at all? Cancel the 2. Yes, that's exactly right. When we cancel the 2.5, we're just going to put the x up front so it doesn't get lost back there. So the derivative is x times x squared minus 1 to the 5th. Yeah. So with that sitting there, if I were to ask you for the antiderivative of x times x squared minus 1 to the 5th, I bet you would know the answer. What is the answer? What is it? Yep. Yep, 1/12. Mm-hmm. Yeah. If the derivative of 1/12 x squared minus 1 to the 6th is x times x squared minus 1 to the 5th, then the antiderivative of this is that. Right? They're inverses of one another. What one does, the other undoes. But guess what? You're not always going to have something like that to look up to get the answer. So we have to find a way to integrate compositions of functions on our own. And it's called U-Substitution. We're going to be working the chain rule backwards. So, first thing I want you to do is notice what happens when you take the derivative of a composition of functions, what those derivatives always have in common, what they look like. If you found what is the derivative of the ln of sine x? 1 over sine x, but then you have to multiply by cosine x. So we're not going to simplify. I know it's cotan x, but u prime over u, or 1 over u times u prime. All right. What about the next one? What is the derivative? 2 plus 1 first times 5. Derivative of the inside. Chain rule. One more here. That's the derivative of the last one. Times 6x squared. Every one of these has this guy trailing along. And who is that guy? Where does he come from? Yeah, that's just the derivative of the inside. So if we even hope to work it backwards, a composition of functions backwards, we got to have the derivative of the inside sitting there to begin with. If I want to take the antiderivative of this, I'm going to get this. But to do it, I need this there. If I want to take the antiderivative of 2x cubed minus 4 to the 4th, I need this here. I'm not going to be able to do it. I need the derivative of the inside sitting next to it so I can work it backwards. All right, so, yep, okay. Where? Like, well, okay, but like if I asked you to find the antiderivative of 5 times 2x cubed minus 4 to the 4th, if I have the 6x squared there, you're going to be able to get the answer. But you can't just put something that wasn't there. Because when you find an antiderivative, you're saying, okay, this is the derivative of what function. And as long as the inside's there, forget about it and just work the power rule on this part. Think of it as like 5u to the 4th. Add 1 to the exponent, multiply by the reciprocal. Bam. You're going to be able to use all your normal rules as long as the derivative of the inside is there. So all of them have the derivative of the inside function. So we can't go backwards until it's there. We're going to get it, and then we're going to forget about it. It'll make more sense when you see it, but suppose y equals some function of u, and u is a function of x. What would the derivative dy dx equal? Let's use the chain rule. So what would you do first to get the derivative of f of u? Yep. Right? You take the derivative out of the function, you leave the inside alone, times u prime, or times du dx. I'm going to use du dx today. So if we wanted to work this backwards, and just see what we just had, then the antiderivative of f prime of u, as long as I have du dx here, oh, first of all, let's see how it's going to look, because we're not going to always see a du dx there. What do you think I can do to simplify this? I have f prime of u times du dx times dx. What cancels? Yeah, what you're going to see is just the antiderivative of f prime of u du. just realize when you see a du there, that's really the derivative times dx. What should I get then if I'm working this backwards? Well, remember we said, yeah, it's just going to be f of u plus c. If the derivative of f of u is f prime of u times du dx, and when you work it backwards, as long as you have a derivative there, you can forget about it. You're just going to get f of u. We're just working it backwards. So we can only integrate f of u if we have the derivative of the inside, du dx. This is like, I know I'm like killing it, but now let me just see if just make sure you guys got it. So if you want to integrate, let's say g prime of u, and you've got du dx here, right there, it has the derivative of the inside function is right next to it. You can simplify it. So what's it going to look like? Good. And if you have the antiderivative of g prime of u, du, yep, what are you going to get? G of u. Let's see. All right, now we're ready to start our little process. But I just really want to stress that you always have to have the derivative inside there. You got to have du if you want to integrate a function of u. Now our first example, we've actually done it already. Remember we got the answer a couple of minutes ago because we saw that right above it? Okay. But this time I'm going to show you the real process to do it. For U-substitution, you let u be the inside function. Now you don't look at a problem and you're going to say, what should I make u? Well, you look to see what the inside function is, because this is going to help you integrate compositions of functions. So if you had to guess, what do you think u might be? X squared minus 1. I'm going to write that over here also, just because this is how I usually do it. Now, there's no way we can integrate a function of u unless we have the derivative of it. What does du dx equal? 2x. But we know we're going to cancel that, so we really just need du. If you wanted to solve for du, what would du equal? Du would equal 2x dx. You can just bring the dx to the other side. Now here's the thing. Once you decide on u and you get du, think of this du as being like a shopping list, or like a recipe. You can't even start baking the cake unless you have all your ingredients. All your factors of du have to be in the problem. Let me just write this problem here. So we're trying to integrate x times x squared minus 1 to the 5th dx. So I'm going to work backwards. Do I have a dx in the problem? Yes. Right there. Check. How about an x? Now, when you look for an x, you can't choose something you've already decided is part of u. Like, I can't choose an x here. I'd have to choose it here. But we got it. What am I missing? A 2. So if you're missing a constant factor of du, it's okay. Like, if I'm missing an x, I'm out of luck. I can't integrate. But if I'm just missing a number, just go ahead and put it in there. But that changes the problem. So if I multiply by 2 on the inside, what am I going to have to multiply on the outside to compensate? 1/2. So if you need a number to have all your factors of du there, put it in. Just multiply by its reciprocal on the outside. 1/2 on the outside. All right. Factors of du are there. We're going to switch everything over to u's and du's. No more x's. Now this 1/2 out here, any number outside is going to stay. But I want to write this integral in terms of u and du. You guys see where u is in this? Remember what u equals? That's in parentheses. So if I were to replace this part, how would I rewrite that part? u to the 5th. Always save your du for the end, else it just looks weird. Now, what's left? What can I replace the remaining terms by? The 2 times the x times the dx. What is the 2x dx equal to? Du. Who wouldn't want to integrate that? Everyone wants to integrate that, right? You see how now it's nice and easy? We made a substitution that's going to allow us to use one of our integration formulas. So let's integrate half. What is the antiderivative of u to the 5th if you've got the u? 1/6 to the 6th. Let's see. Now, when I give my final answer, they gave me a problem in x's. I'm not going to give them an answer in u's. So we're going to get, oh, remember that, the 1/12, 1/6 times a half. I'm not going to write u to the 6th. Remember what u is equal to? X squared minus 1. Let's see. We got it ourselves without just having the answer above us. But think about what we did. We chose u to be the inside function. We took the derivative of u and multiplied by dx, so we'd have du. If we were missing a constant factor of du, we had to put it in and put its reciprocal on the outside. Once you've got your du factors there, you rewrite it in terms, your integral in terms of u and du. You take the antiderivative and switch back to x's. Pretty easy. All right, we're doing another one. Let's go to, what do I have now there? All right, pick something good. Pick something good. 2? I like 2. I kind of like 2. There's a reason. 2 is like the hardest one I see. I know. Then we can do another one. All right, first of all, guys, sometimes you're going to have a constant. You might not want to have it there. You might just want to pull it out to begin with. And I also know I'm going to rewrite this. I'm going to pull the 8 out. But I'm going to consider this to be x times 2x squared minus 3 to the negative 3 dx. You know, when you're trying to use the power rule, you got to bring it up. Power rule is only in the numerator. Power squared numerator. Okay. Your first thing you got to do is decide who gets to play the role of u today. What is your inside function? 2x squared minus 3. So I'm going to write u equals 2x squared minus 3. Now, I can't integrate any function of u unless I have du. So take the derivative of u, so du dx equals 4x. And usually I kind of skip this step. I go right to du. So du then would equal, 4x dx. All right, we got to see if we have all the factors of du in our problem. Do we have the dx? Yep, check. Do we have an x? Yep, there it is. Now, what about a 4? If you wanted to, you could bring back a factor 4 from the outside, but I'm just going to leave what's outside there. We need a 4. So I'm going to put in a 4, which is cool. But what do I have to do on the outside? If I've multiplied inside by 4, I need a 1/4 on the outside. So what number do we really have on the outside? 2. Because we're going to rewrite this integral in terms of u and du. Save the du for the end and tell me what this would look like in terms of u and du. You found your u. Well, no, you're only replacing the 2x squared minus 3 with a u, so it's still u to the negative 3. We're not taking the antiderivative yet. We're just rewriting it. So that's u to the negative 3. And what about the 4x dx? That's just your du. we can integrate that. We're going to use our power rule. Let me just leave the 2 there. If you add 1 to the exponent, what do you get? -3, -2, and then you have to multiply by the reciprocal of the new exponent, -1/2. So we get, that's just -1, u to the -2 plus c. See, that's just, to work it backwards, you need the derivative of the inside there. That's why I'm trying, like, because people think, oh yeah, du turns into a c. No, du doesn't turn into a c, okay? It has to, yeah, the inside, okay? Now it has to be there to work it backwards. And so u is 2x squared minus 3. So that's it. I mean, you could rewrite it as -1 over 2x squared minus 3 squared plus c. I'm going to fit one more in. We can do it. Isn't that cool? Is there one more we could just at least decide on you? Pick another one. 4. Oh, because I see signs. I see cans. What do you think for number 4 we should make the u be? Tan 2x. This one, I'll tell you, you don't even have to pull the 2 out. You'll see it in a second. Because what's du going to be? What's the derivative of tan of 2x? Secant squared of 2x times 2, and then the dx. We have every factor already there. We don't have to put in anything. It's all there. So all we have to do is rewrite it. If we rewrite this in terms of u and du, what's it going to be? Find your u right here. So it's going to be u to the half. And what's the rest of that? 2 secant squared 2x dx. We're going to replace with the u. You rewrite it. You take the antiderivative. What's the antiderivative of u to the half as long as you have the u? Well, if you add 1 to a half, what do you get? 3/2. So that's why you have to multiply by 2/3. And then you just put the tan 2x back in for u. So 2/3, it'll be tan of 2x to the 3/2 plus c. And if you don't believe me, take the derivative of it. Using your chain rule, you'll get right back to where we started. Working the chain rule backwards. It's awesome. How did I get du here? Had to use the chain rule. Derivative of tan of an angle is secant squared of the angle times the derivative of the inside is 2. And then I went right from u to du. So you got a nice homework sheet. The last 2 are going to be ln. So if you just want to do the first 8 for the power rule, so I think you might want to try the last 2. I think you guys, if anyone can do it, you can. Historically, which does like a month and a half. It would have been helpful.